I mean, we did this yesterday. We're doing it again today.
You got those are orange. Do it actually taste like orange juice? Or no. Watered down.
Okay, so if we look at the problem of conservation of mechanical energy, here it's actually giving you, starting from rest, the child zooms down a frictionless slide, initial height of 3 meters. What is her speed at the bottom of the slide? Assume that she has a mass of 25 kilograms. So we have our height initial at 3 meters. A velocity initial, she hasn't started yet, that's 0. Her mass is 25 kilograms, and we're looking, and we said her height final is 0. So that means she's going down to the very bottom of the slide. We're looking for velocity final. So what I would like you to do is where you see the calculation solution. Does everybody see that on number 3?
Calculator.
Okay. What I would like you to do is I would like to have you do the one on the right-hand side to make sure that they balance. Oh, wrong one. What mode should we have it in?
Just doesn't matter, radian or degree.
Yep.
But like not at practice. Oh, after Mason, did you say something? He says something to me. I was about to say something. They took you off for your hand, and they were like, I was like, I don't want him here. He ain't got no hands. What's Mason in here? He's got best hands in the team. He goes, I jumped on it.
How was everybody's math? Is everybody good? All right, cool.
I mean, it was off by 0.6.
Yes, it was off by 0.6, but
like, let's not assume that it's correct because of that.
right. But that is the answer that you got, though, right?
Something like that.
Okay, cool. All right, so let's go on to question number 1. Okay. So it tells us a bird is flying at a speed of 18 meters per second over water when it accidentally drops a 2.0 kilogram fish. If the altitude of the bird is 5.40 meters and friction is discarded, what is the mechanical energy of the system, and what is the speed of the fish when it hits the water? Okay, so what you're doing right now in your ISM book is you're writing down the variables and seeing if you can figure out what the problem is.
I was going to say 2.
Okay, when you get the answer, please raise your hand. So the variables are on the board. You have velocity initial, you have height initial, you have mass, and you have gravity. Read your problem again. See if you can figure out what the variables are. And then I gave you the formula that you're using. And then you're plugging it in.
What does it mean? Oh, never mind.
Mechanical energy.
Figure it out. I'm so confused. I don't know what's wrong. Like we just common control.
Yes, ma'am, we'll bring some. When you get it, call me. You're fine. Write it down. Yeah, you're right. What is the units? What is the units, sir? What's the units, Gabriel?
Meters per second.
No, it's not. We're talking about mechanical energy.
Joule.
Joules. Yes. Put those out. Put those in.
That thing lied to me.
All right. Thank you.
Is this it?
Thank you.
Oh, wait, it is? Oh, snap.
That thing's not.
Yep. Yeah.
That fish might really
Yeah.
not have to, and the energy out, did you not have to?
Work on number 2 if you got it.
Oh, I don't have it up.
Okay. Huh? Yeah, it looks like I did it. Okay, your velocity one should have been 18 meters per second. Your height one should have been 5.40 meters. Your mass should have been 2.0 kilograms. And your gravity should be 9.81 meters per second squared. So what you're going to do is you're going to take your 2. You're going to times that by your 9.81. You're going to times that by 5.40. Adding 18.0. And that should have gave you 429.9 joules. And that is your answer.
But it's only the 3 significant figures, so it would be 430, right?
That, yes.
Did you?
She did nothing wrong.
Never mind. More me.
Are you okay? Okay, so are we ready? So it asked us what it was the speed of the fish when it hit the water. So now we're going to go on to number 2. 755 Newton diver drops from a board of 10 meters above the water surface. Find the mechanical energy of the system and find the diver's speed at 5 meters above the water surface. Then find the diver's speed just before it sank in the water. Did you do the second part yet, ma'am? With this question?
That's wrong. I didn't have. More math than math class.
So I forgot, even though she reminded me, there was a second thing that it asked us for, is it not, in this first question?
Oh.
I am so sorry. So it was asking us, after we found our mechanical advantage, then it was asking us to find what the velocity final is.
You square rooted it all right. You just got lazy.
I'm getting ready to go up there and do it.
You just
Your eyes are right there where my eyes are. Because I just saw that and I'm like, oh my God, they don't know they square root the whole thing.
and then you also didn't put a square root of 18 at the top. But that's unimportant.
Oh.
God bless you.
She did nothing wrong. Oh, but she did nothing wrong.
Thank you, Gabriel. He's always supporting me. All right, did you understand how I got this for question number 1 still? How are we doing with question number 2?
I don't know what that
That's what I
means.
was saying with the meters.
Where's the formula?
She's big brain. You know.
Which formula? This one?
Yeah.
Velocity final? We did that before. Remember when we did velocity initial, or we're looking for velocity final? That, I think it was in last chapter or the chapter before. But I'm gonna give you the formula anyway. Huh?
That can.
Okay.
Gabe, have you seen that Hot Boy song? That Hot Boy song? That Drake made?
All right, let's stop there for right now, because I want you to finish your exam.
Oh.
So please go finish that first.
Oh, I didn't. Hey, I'll still answer that. That's on like 2.69 or something.
3.7.